I start with compound interest, which involves a formula. This formula you will not have to have memorized. This will be given to you. But it looks like this. We've got compound interest formula. So we have A equals, and then we've got a capital P on the outside, set of parentheses, 1 plus R over N, and then on the outside, as an exponent, we have N times T. All right, so what I'm going to do is walk you through what each little bit of those things mean. So A is the current amount, and you're usually talking about money, so we're talking about it being in a bank account or whatever. So A is the current amount. So if you're trying to calculate how much there is after a certain amount of time, that's what you're solving for is A. Capital P stands for principal, so it's the current amount, or I'm sorry, the initial amount that you put in. It's like if you opened a bank account, you put in this much money. So the principal amount or the initial amount. R is the rates, the annual interest rates. And then we've got N, the number of compoundings per year. Oops, that says year, not very clearly. Let's try that again. Year, Y-E-A-R. There we go. Okay, and then T is time. Okay, so we are going to do one of these compound interest problems. So an investment account pays 5.4% interest compounded quarterly, so that is R. Compounded quarterly, that is N. $4,000 is placed in the account, that's capital P. Find the balance after 8 years, that would be T. Okay, so we've got all of those pieces that we're going to plug into this formula. So like I said, you don't have to have it memorized, it'll be given to you. So the current amount that we are looking for is we've got the principal, which is $4,000. And then we have 1 plus. So the rate, be really careful, it's always going to be given to you in a percentage. Make sure you convert it to a decimal. So 5% is 0.054, that's the rate. And then over the number of compoundings per year. So if it's compounded quarterly, quarterly would be 4 times a year. And then if we raise it to this exponent, so we've got 4 times a year, and then 8 years. All right, so we're going to plug all that in. I, of course, forgot to actually bring my calculator home, so I'm just going to use my phone calculator. So I'm going to start kind of on the inside here and do 0.054 divided by 4. Okay, so that's this piece, plus 1. So that's all of this. And then we're going to raise it. So raise that to the 32nd power, because that would be 4 times 8. This is this, and then times the principal amount, which is 4,000. It'd be really neat and clean to plug into your calculator if I had remembered to bring it. So $6,143.56. All right, so that's how those compound interest problems work. It's just knowing how to plug everything into that formula, which would be given to you. So this would be your final answer. And then the next big thing we're going to do is these exponential inequalities. Very, very similar to what we did with the equations. So once we have the actual formula set up, it's really similar to the ones that we were doing before. So it involves getting a common base, just like we had to do with the equations. So if we say, that B has to be greater than 1, these ones don't work if we're dealing with like the fraction ones. So if we start with B being a positive number, so B to the X is greater than B to the Y. So let's start with if. Then that means that X is greater than Y. We had just one of these set up for equations, but since there's 2 different types of inequalities, we'll have 2 statements here. Then if B to the X is less than B to the Y, that means that X is less than Y. The exact same would hold for less than or equal to or greater than or equal to. So let's just add a little addendum here. So the same holds for less than or equal to or greater than or equal to. So I wrote it down as just less than or greater than, but if you had the or equal to, the property would be exactly the same. So we're doing the same thing that we did in the part A video, where we've got to get these things to have the same base. So that's what we're doing. So for part A, 3 is already a prime number, so the left-hand side is good to go. So we're just going to leave this as 3 to the 2x minus 1 greater than or equal to. Now 1 over 243, we need to write that as 3 raised to a power. So 243 is 3 to the 5th. That's one of those ones that either you have memorized or you can kind of figure that out. And remember, if you see the reciprocal, because it's 243 down in the denominator, that means this would be the negative 5th power. So like this thing right here would be 1 over 3 to the 5th. So we could write it as 3 to the negative 5th power. Anytime you see a fraction like that, this one, you know it's going to have a negative exponent. So if we use this property right here, we know if the bases are the same, that must mean that the power is greater than or equal to the power. So you can just set that little inequality up over here. So once you have the bases equal, most of the hard part is over. It's just solving this inequality. So I'm going to add 1 to both sides. I get negative 4 and then divide by 2. So greater than or equal to negative 2. So that would be my final answer. What that means is if I sub in a value of x that's bigger than negative 2, that would make this inequality true. Otherwise, it would be false. So you can always plug things into your calculator to kind of test things out, do a true-false check. So let's do one more of these. So 5 is already a prime, which means the left-hand side is good to go. No changes necessary. Greater than, and now 625, we can again write it as 5 raised to a power. So because this is a reciprocal, it's going to be a negative power. We know that for sure. And then 625. So 5 times 5 is 25. Times 5 again is 125. Times 5 again is 625. So that would be the 4th power. And again, it's negative because of the reciprocal. So I do the same thing I just did up above. Set up like a teeny little inequality. Just comparing power to power. And then I will solve. So I'm going to subtract 3 from both sides. So I have negative 2x is greater than, this is a negative 7, and I will divide both sides by negative 2, and I'll be super, super careful here. Remember one of your inequality properties, if you divide by a negative number like that, you have to flip the sign. So this now becomes a less than, and then the negative over negative just reduces down to a positive. So same idea, if I plug something less than, this is 3.5, less than 3.5 in here, my inequality would be true. If I plug in anything different, my inequality would be false.